I use dynamic sampling, simulated annealing to figure out like what kind of weights you want. And then the thing is, like, you don't really know much about the distributions of the inputs that you get, and sometimes you want the distribution to be in a certain way. Sometimes you don't know what that distribution is, and you just want it to be pretty uniform. So what my research project is looking at is how do we tune these generators so that we get the distributions that are good, that the programmer wants. So the way these input generators are like non-deterministic is that there are like points where for example, it branches between terminating like for a list generator, it'll choose between terminating with like a nil list or appending some random integer with like whatever recursive call. So there's like two cases, like terminating case and then like a recursive call. And then so what I do is it chooses these 2 points deterministically. Like it uses like a Boolgen to do that. And then what I do is I first like replace the Booleans with in OCaml. So in OCaml there's QCheck, which is the party-based testing framework. And then in QCheck they have a way of specifying the like weights for some between two generators. Mm-hmm. So basically, I put these two paths into this thing called frequency, basically FrequencyGen, and then there are weights that I need to take. So what we need to figure out then is like what weights or how often should I choose branch A between branch B so that we get the data that we want at the end.